Alright, so we're going to be looking at a couple examples for conservation of energy. So here we have that roller coaster picture that we kind of saw in the notes. And we're going to label where is potential, where is kinetic, and how is it transforming as it is going. So if we are going to go up that hill, at the very, very top, we're going to have that potential energy like we said. And then as we go down that hill, potential energy is turning into kinetic energy. And then as we're at the bottom of that hill, kinetic energy is all that we have. As we move back to the top, we have that kinetic energy now turning into potential energy. And then once we're back at this top, we have potential energy again. And then we're going to be going back down, turning that potential energy into kinetic energy. So like we said, the law of conservation of energy states that energy is not going to be lost. It's going to be transformed into one type of energy to another. Now we have this picture. Think of a ball on a string swinging back and forth when we're looking at this picture. At the very top of the swing, we're going to have all potential energy. And then let's move down here. So this ball's swinging down. We have potential energy turning into kinetic energy. As it's swinging back down again, we have, again, potential energy turning into kinetic energy. And then at the bottom of the swing, it's going to have all kinetic energy. As it swings back up, that kinetic energy is turning into potential energy. And then as it's back at its peak, it's going to be all potential. That is true for when it comes back down. So when it swings back down, that potential energy is turning into kinetic energy. And then when it's back at its lowest point, it is all kinetic again. And then as it swings back up, that kinetic energy is turning into potential energy. And then as we're back here, it's all potential again. And then our last picture that we have that we're going to look at is, let's say that we have a ball at the top of this building. And let's give the ball's mass of 10 kilograms. And let's give the building a height of 100 meters. So we can solve the ball's potential energy. Potential energy again is mass times gravity times height. So the mass of the ball is 10 kilograms. That gravity again is always 10, and the height would be 100 meters. So we're going to multiply all those together to get 100 times 100 to get 10,000 joules. So we have potential energy of 10,000 joules at the very top of the building. Now we can look at, let's say the ball is now falling and it is halfway down the building. We're going to be looking at its potential and now its kinetic. So halfway down, meaning it is now only 50 meters above the ground. So again, its mass would be 10. The gravity is always 10. And then the height now is only 50. So in order to get that, we're going to multiply 10 times 10 to get 100, 100 times 50 to get 5,000 joules. So if we have 5,000 joules of potential energy halfway down, that means that 5,000 joules of kinetic energy is now in this ball. Because looking back up here, our total mechanical energy is 10,000. And that's going to be true as this ball is falling. So looking at these two, 5,000 plus 5,000 will give you that 10,000 joules of total mechanical energy. So as this ball is falling, it's turning its potential energy into now kinetic energy. As this ball is falling all the way down, and let's say it's about to hit that ground, that potential energy is going to be 0 joules. There is no more potential for that ball to get. And now looking at kinetic energy, because it had 10,000 joules of kinetic or potential energy at the top, it's going to now have 10,000 joules of kinetic energy at the bottom. And again, if we add those up, we're left with 10,000 joules of total mechanical energy. So that is the law of conservation of energy, how it can be represented in multiple ways, and that is it.